Hello guys, in this video I'm going to be teaching you these subtopics under physical quantities. First of all, what are physical quantities? These are quantities that can be measured, therefore we can quantify them. What do we mean by measurable quantities? Quantities that have magnitude. That means any physical quantity that we can measure by magnitude is regarded as physical quantity. For example, mass, length, density, force, speed, etc. They are examples of physical quantities. Magnitude can be a positive integer. Say magnitude, positive integers such as 5, 6, 8, 0.2, 0.5, etc. Can also be a negative integer of -1, -3, -2.8, -5.2, etc. That's what we mean by magnitude. In physics, there are various physical quantities. Therefore, I came up with a chart to help us simplify the types of physical quantities. So, as we can see on the screen, all these are the classifications of physical quantities. We have basic and derived quantities. We have scalar and vector quantities, then we have dimension and dimensionless quantities. So let's start by analyzing the first classification of physical quantity, which we have basic and derived quantities. Basic quantities are quantities that are independent of other quantities. They do not depend, they are not derived from other quantities. Sometimes we call them fundamental quantities. In physics, there are 7 basic quantities, and the table below helps us to analyze the 7 basic quantities with their respective units and symbols. So as we can see on the screen, there are 7 basic quantities that we have. We have mass. We have mass. The unit for mass is kilogram. We are using the SI unit. Then the symbol for kilogram is kg. We have the length. The unit is meter. Then that's M. We have time. The unit for time is second. Then that's S. We have current. The unit for current is ampere. Then symbol is A. We have temperature, Kelvin and K. Then we have our amount of substance. Then we have the luminous intensities. So we only have 7 basic quantities in physics. Now let's talk about the derived quantities. The derived quantities are quantities that are obtained or derived from the basic quantities. When one or two arithmetic operation is performed on the basic quantity, we will obtain the derived quantities. So apart from the 7 basic quantities we can see on the screen, others are derived quantities. Examples, we have area. Area is a derived quantity. We have volume. We have density. We have pressure. We have force, and so on. They are examples of derived quantities. So we have looked at the first classification of physical quantity, that is based on the basic and the derived quantities. So you can feel free to pause the video and jot down some things. Let's now look at the scalar and the vector quantities. So talking about scalar and vector quantities, we can differentiate between the two by using the concept of magnitude and direction. Magnitude and direction. Magnitude, as we have discussed the other time, magnitude simply means size. And the size, we use numbers to represent the size. So it can either be positive or negative. Positive or negative numbers. So when we are talking about the direction explain the fact that a quantity can either be on the positive axis or negative axis. So we use plus or minus to represent the direction. So starting with the scalar quantities or scalars, scalar quantities are quantities that can only be described in terms of magnitude and no direction. Scalar quantities, they only have magnitude. That means, for example, we have 5. 5 is the magnitude. Then we have kilogram. That's to represent the unit. So when we write 5 and kilogram together, we have 5 kilogram, and that represents the quantity of mass. Same quantity of mass. So another example is we have 6, then I'm having unit of, let's say, unit of joule. So combining the two together, that will give us 6 joule. So scalar quantities, they only have magnitude and no direction. They only take a positive integer. Examples of scalar quantities, we have the distance. Distance are a scalar quantity. We have work, we have power, energy, etc. Discussing the vector quantity. Vector quantities is the opposite of scalar quantities. Vector quantities are quantities that can be described in terms of magnitude and direction. They have magnitude. That means they can have, they always have a number and have direction. So they can either be positive or negative. Positive or negative. So examples of vector quantities include force, displacement, acceleration, velocity, etc. So one way to understand the vector quantities is that a vector quantity can be positive and can be negative. For example, if I have 5 and then I have meter per second, this is not enough to say is a vector quantity. It can either be positive, then we can also have -5, and we have meter per second. So in this case, we have, when we join together, we are going to be having +5 meter per second. Then this one will give us -5 meter per second. So a scalar quantity will only have a positive integer with the unit, while a vector quantity can either be positive and can be negative. When scalar quantities, when they possess a negative integer, doesn't signify that they are traveling on the negative axis or the positive axis. When you have a negative integer, you have another interpretation. For example, when you have work, when work is, for example, -10 joule, this does not mean that the work is moving along the negative axis, either positive or either the negative x-axis or the negative y-axis. It is only explaining that work is done on the system. Work is done on the system. Another example is let's say energy is -12.5 joule. This is not explaining that energy is traveling along the negative x-axis or negative y-axis. It is only explaining that energy is lost or dissipated. So now let's look at a table that explains the scalars and the vector quantities. Scalar and vector quantities. We have distance, and the opposite of distance in terms of vector is displacement. Displacement is a vector quantity, while distance is a scalar quantity. Another example is speed. Speed is a scalar quantity, velocity is a vector quantity. An example is work. Then we have torque. Torque is a vector quantity as vector quantity. So we have analyzed the scalar and the vector quantities. So let's look at the third classification of physical quantities. So what are dimension quantities? As the name implies, they are quantities that have dimensions. Dimensions is just, like I've said, is the exponent to which the basic quantities are raised in order to represent that quantity. So let's look at the basic quantities and their dimension. But before that, in physics, whenever we write this square bracket, it means dimension. This is what we use to represent dimension in physics. Simply means dimension. Let's look at it. The basic quantity and their dimensions. So starting with the first one, mass. Dimension of mass is capital letter M. Length is L. We have time, C. We have number 4. We have current. Current is A. We have temperature. The dimension for temperature is theta. Then we have amount of substance. Amount of substance having dimension of N. While the last one is luminous intensity. That is G. These are the dimensions of the basic quantities. Feel free to pause the video and jot down some things. Now, if we have all these dimensions, if I want to write dimension of mass, as dimension of mass is N. Let me change the ink. Then we have dimension of length, all right, as L. Dimension of time, right, as T. And dimension of current, it as A. Then dimension of temperature, right, as theta. So among the 7 basic quantities, the frequently used quantities in science, we must be familiar with, is 5 out of the 7, and as a result of that, I was able to get a mnemonics in order to understand the 5 that we always make use of, and that we have molat. Call it molat. So molat as dimension of the dimension of mass, dimension of temperature, dimension of length, current, and time. So these are the 7. These are the 5 that always make use of in most times in physics. Let's talk about the dimensionless quantities. So dimensionless quantities, they are quantities that possess no dimensions. They don't have dimensions. In another way, I used to say that they are quantities, whenever you solve for them, you get 1. When you solve for the dimension of a dimensionless quantities, you obtain 1. And you can say that it is dimensionless. Examples of dimensionless quantities, we have refractive index, we have strain, relative density. They are all examples of dimensionless quantities. So in our next video, we are going to look at how refractive index, strain, relative density, how they are dimensionless quantities. So apart from the 3 classifications of physical quantities we have discussed above, another class is the supplementary quantities. Supplementary quantities, that down, is the supplementary quantities. There are 2 types of supplementary quantities: the plane angle and the solid angle. Then we have the solid angle. They are the supplementary quantities that we have. Now let's look at a table to help us understand the supplementary quantities. So, as you can see on the screen, these are quantities that we have. We have the plane, then we have the solid. The plane angle, their unit is radian, while the solid angle is steradian. They are both dimensionless, or we can say that dimensionless, or just use 1. Dimensionless or 1. mean dimensionless, that means dimension is equals to 1. So this brings us to the end of physical quantities. Feel free to go through the video and subscribe to my YouTube channel at Science Made Easy.